Hi, YouTubers. We're investigating graphite felt and nickel-plated, electroplated graphite felt. And that would include the graphite felt fiber sheets and also pretty soon a graphite carbon fiber rope. In this exercise, I call this dry circuit. We have a 5-watt rated LED. We did not run a DC motor with this. We simply didn't want to worry about heat or the noise in the laboratory. I'm doing this in my office right now. A 5-watt rated LED as the load. That has about 6 or 8 ohms resistance. In this dry circuit, a very simple setup. We just set this up. It's at 5.56 volts, and it's running at 430 to 440 plus or minus milliamps. Let's say it'll average out to about 435 with this device. I don't have a fine control on here, constant current. So it's been pretty steady here at the beginning. We've run these up to 10 days consecutively, day and night. Checking for any heat or any problems. We haven't seen it. And in this, what I call dry circuit, electrical engineers do not call this a dry circuit. To them, that's working with basically microamps with some important applications. We are calling this a dry circuit because inside these dummy AA cylinders, which I get on eBay, they're very cheap, very handy. We have some graphite felt. You can see some of it here. Commercial graphite felt rolled up inside the dummy AA, and it's in a cradle. And there's no solvent, no electrolyte. We're simply running 435 milliamps. I would not go above 750 milliamps with a breadboard, but we want to just see how it behaves. We did not clean this graphite in the prescribed manner, alcohol, drying it. There's no nickel plating. It's right out of the bag and tucked inside the dummy AA in a cradle for convenience. Now, later on, we'll do a wet circuit, and that will have, for example, lithium tetrafluoroborate in DMF or methyl carbonate solvents, anhydrous solvents. We're doing supercapacitor work, but we want to see how this will perform. We'll bring it up to 3/4 of an amp, and it's in a closed system, but there's going to be airflow there. I did not completely seal it. We've not been seeing any problems with this. The dummy AA's, we get them on eBay. There's a length of 46.9 millimeters, and the diameter is 12.6 millimeters. So we pop them open. We leave that small piece of wire connecting both, and that's wrapped. That wire lead is wrapped around with the graphite felt inside the cylinder. So we just want to see the behavior of it this way. And then it'll be interesting to run this with the electrolyte and the solvent for the same amount of time to see if the surface area becomes modified. And then we examine these with scanning electron microscope. I'll keep you posted on updates. But before even doing supercap work, I like to see how the system simply behaves in a simple closed circuit. Thank you for watching. Bye for now.